Okay, now I'm going to start talking to you a little bit about what we call a reference angle. Reference angles are really important because they help us out. When you have a reference angle, and a reference angle is going to be a first quadrant angle, it's going to be acute. What we can do is we can use the fact of the symmetry that a circle is symmetric to the x-axis and to the y-axis, the unit circle here. So that makes it really easy to find three other angles knowing one. For example, if I know where this point crosses right there, for this angle right here, then this ordered pair, let's just call it, give it a name, x and y. So I'm going x over, y up, right? X to the right, y up. Well, if I have this angle here the same size, so that would be 180 and then back this amount. So this is alpha, this would be 180 degrees minus alpha. That would be all the way to there and then back. So it goes to here. This ordered pair, see, I'm going to go the same amount because of the symmetry. I'm going to go the same amount but to the left and then the same amount up that I did for alpha. So this ordered pair right here would be the opposite of x, y. So if I know this one and I can keep track of my signs, S-I-G-N, signs, then I know these ones as well. So like if this is 20 degrees, then I also know for 180 minus 20, I also know for 160 degrees. I'll be able to, if I know the sine, or the cosine and the sine, then I can figure out the cosine and the sine here for this angle as well. In the third quadrant, and again, this is supposed to be alpha here. Alpha is what I usually call my reference angle. It looks like a fish, okay? Then this angle would be all the way around here would be 180 degrees plus alpha more. So this would be 180 degrees plus alpha. Now, of course, there are equivalences for radians because 180 degrees and pi radians are the same angle size. So I could be, if I have to do this in radians, I could use pi minus alpha, pi plus alpha. But for right now, degrees, because I think it's a little easier for you to understand, it would be 180 degrees plus this much more, alpha more. And if I wanted to find this point, notice it's the same amount over to the left and the same amount instead of up, down. So this point right here would be the opposite of x, the opposite of y. Do you see how these values are either the same or they're opposites? Well, as long as I can keep track of all students take calculus and I know when it's positive and when it's negative and keep track of my signs, S-I-G-N signs, I can figure these out. So like again, if this was 20 degrees, this would be 160, this would be 200, 180 plus 20. So one more to go in the fourth quadrant here. If I want to find this point right here, notice that it's going to be x over y down, x to the right, y down. This would be x opposite of y. This would be for the angle. Now I'm going to put them in the inside here, so hopefully you can see this. This would be 270, keep on going, but remember this part's alpha, so it would be 360 and then back. This would be 360 degrees minus alpha, or 2 pi minus alpha. And I would have enough knowledge that I could be able to figure that out. So if this is 20, then it would be 360 minus 20 would be 340 degrees. So if I know 20 degrees, I can find out stuff about 160 degrees, I can find out stuff about 200 degrees, I can find stuff about 340 degrees. If I know the sine and cosine of those, I can figure out the sine and cosine of those without anything else other than keeping track of my signs, S-I-G-N signs. So I know that's kind of messy and that's a lot, but that's the idea of a reference angle. You have to remember, calculators haven't always been around. They used to use tables of values, and the tables only went up to 90 degrees. So if you wanted to figure something bigger than 90, you had to use the idea of the reference angle and keep track of your signs, S-I-G-N signs. Now, if they give you an angle and they ask for the reference angle, I'll show you how to find it. But before I do, remember how we had just in the last video, just the first quadrant of angles? Remember that for 30 degrees, this point here turned out to be the square root of 3 over 2 and that 1/2. Well, look what happens over here. Now remember, this is 30 degrees here. So in the second quadrant, it would be 180 minus 30, so it would be 150 degrees. 150 degrees. And look what I have here. I go x over y up, this would be negative square root of 3 over 2, positive 1/2. So the cosine of 150 degrees is negative square root of 3 over 2, the sine is 1/2. And in the third quadrant, where the sines and cosines are both negative, that would be, if this is 30 here, that would be 180 plus 30, that'd be 210. I'm kind of crossing these out, this was 150 here. Okay? Then what happens here is I go the same amount over for the x and then the y down. This would be negative square root of 3 over 2, negative 1/2. So for 210 degrees, which again you could have this all in terms of radians as well, that'd be 7 pi over 6 radians. The cosine is of 210 degrees is negative square root of 3 over 2. The sine of 210 degrees is negative 1/2. Alright, and then in my fourth quadrant here, this would be all the way around back 30, so this would be 330 degrees. Let's see if I can scoot him in here. Here, I'll go all the way around like this. So this is 330 degrees. This point right here would be the same x over, but y down. This would be negative square root of 3 over 2. X over, y down, negative 1/2. There, we got it. So for 330 degrees, the cosine of 330 degrees is the same as cosine of 30. Square root of 3 over 2, and the sine of 30 degrees is just the opposite of the sine of 30, negative 1/2. And I can do very similar manners here. This was here, let's put a true square root here. Square root of 2 over 2, square root of 2 over 2. In this quadrant, remember the x is negative, so this would be negative square root of 2 over 2, negative, positive square root of 2 over 2, because the y is positive. So that would be for what, 180 minus 45, 135. For 225, that would be 180 plus 45 more. This would be negative square root of 2 over 2, negative square root of 2 over 2. So for 225, the cosine is negative square root of 2 over 2, the sine is negative square root of 2 over 2. And then in the fourth quadrant here, that would be all the way around 360 minus 45. That would be all the way around. That would be 315 degrees. And that would be square root of 2 over 2, negative square root of 2 over 2. So I can find the cosine and the sine as well. Now, deducting this isn't that tough. Memorizing it's the tough part, because if you memorize it, you don't have to go through all the rest of the steps. But you will need to be able to come up with reference angles. One more, since I already have it drawn out, I might as well do it here. We did this angle before in the previous video. This had an x value of 1/2. This was the square root of 3 over 2. So that was for 60 degrees. Well, for 180 minus 60 or 120 degrees here, 120, this would be negative 1/2 positive square root of 3 over 2. So the cosine of 120 is negative 1/2. The sine of 120 is positive square root of 3 over 2. For the third quadrant, that would be 180 plus 60 more. That would be 210, or 240, excuse me. That would be this angle, 240 degrees. Yes, 240 degrees. So this would be negative 1/2, negative square root of 3 over 2, because you're in the third quadrant. Both the x's and y's are negative in the third quadrant. And then in the fourth quadrant, which would be 360 minus 60, or 300, this would be positive 1/2, negative square root of 3 over 2. So for 300 degrees, the cosine's 1/2, the sine would be negative square root of 3 over 2. See, if you know these, and then of course the quadrantals here, you can find the sines and cosines of, and therefore tangents, because that's just the quotient, sine over cosine, of all these multiples of 30 and all these multiples of 45 degrees. Now let's say they give you an angle and they ask for you to find the reference angle. Now the first thing I want for my angle that they give me is I want my angle to be between 0 and 360, or between 0 and 2 pi. If it's negative, I'm going to add 360 until it becomes positive. If it's bigger than 360, I'm going to subtract 360 until it's between 0 and 360. The idea being that if I do, by adding or subtracting 360 or 2 pi, depending if it's radians, I'm going to get a different size angle, but I'm going to get a coterminal angle. And the coterminal angle is going to have the same reference angle as the original. So if my after I do this, after I do step 1 here, if my angle is in the first quadrant, well, remember it's got the reference angle is the acute angle, so it's its own reference angle. If I get 47 degrees, first quadrant angle, that's my reference angle. If I get a second quadrant angle, remember I've already done this just in case I needed to. I've already added or subtracted 360 or 2 pi radians. And if it ends up being in the second quadrant, I just set my angle, my second quadrant angle, equal to this if it's in degrees or equal to this if it's in radians. This is 180 minus pi. Remember I had them over here. 180 minus pi, and so on. Or pi, 180 minus pi, 180 minus alpha, pi minus alpha. And then I just solve for alpha like a regular equation. I'm going to show you an example here in a second. If I wanted to determine that third quadrant angle in standard position, if it's a third quadrant angle, then I use this relationship. I said 180 plus alpha equal to the angle, or pi plus alpha, solve for alpha. If it's the fourth quadrant, I set it equal to 360 minus alpha, or 2 pi minus alpha, I solve for alpha. You can see how important it is to memorize these. And of course, if it's in the first quadrant, it's its own reference angle, it's equal to alpha. Okay? So now, I'm going to show you a quick example, and then I'm going to run through some of the problems. Let's say that I have 287 degrees. Notice it's positive, it goes counterclockwise, and I want the reference angle. 287 degrees. Clearly it's not its own reference angle because it's too big. It has to be an acute angle. It's going to be this angle right here. Now in the fourth quadrant, because this is clearly a fourth quadrant angle, remember this starts out at 0, then 90 degrees here, or pi, over 2 radians, then 180 degrees, or pi radians, and then down here is 270 degrees, or 3 pi over 2 radians, and I get all the way back up to here, which is 360 degrees, or 2 pi radians. So you should know what I call the quadrantal angles, the ones that are on the axes there. So I am in the fourth quadrant, and in the fourth quadrant, that's my relationship. Set 360 degrees minus alpha equal to my angle, 287. I didn't leave myself much space here. Solve for alpha. So I'm going to subtract 360 from both sides. I get the opposite of alpha is equal to negative, what's that going to be, 73? If I did that right, you're adding a positive and negative, and then of course that means alpha is 73 degrees. That's my reference angle. I know how to do this as long as I use these relationships. Now I'm going to do some in radians as well, and I'm going to do some where the angle is bigger than 360 or negative or something to show you how to find that coterminal angle. Coterminal, the same, terminal side. So it crosses the it crosses the unit circle at the same point. So it's going to have the same x, the same y, the same cosine, the same sine. Those are important. For example, the sine of 30 degrees is the sine of 390 degrees, is the sine of 750 degrees, and so on. You can find those by adding or by subtracting multiples of 360, or in radians, multiples of 2 pi. Alright, so we'll get on to the next one here next.